Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are in module number 3, lecture 28 on orthographic projections. Just to begin with these projections as a summary, in the last classes we have learned something about first angle projections and third angle projections. There we have learned about the views like front view, top view and side views. For example, here we have a three-dimensional object, and this three-dimensional object we would like to look at in different perspectives. One of them is in this direction, the other one is from this direction, the other one is from this direction. When we are observing from this direction, the projected part is this line and this line, and there is one more line projected onto this opaque plane. Similarly, we will see this one, this line, and this line we will see, and this line we see it like vertical projection of that line. So, this entire line projected into vertical plane, again this line will be projected onto vertical one, and this horizontal line and this horizontal line we will see. So, if we are comparing these boxes, this A part corresponds to A part of this line and B part is B part of this part, and C projected version. So, we will see as C prime, whatever that big rectangle projected onto that plane. Similarly, let us look at other views. For example, if we are looking from top view, this entire part we will be in a position to observe. This as it is like a rectangle, and this inclined part we will see as projected version. So, this is front view, this is top view, and side view is this. So, for side view we are looking from this direction, from left to right we are observing it. So, the view what we will see is, let us use some other color, this vertical line and this one which is mapped with this line. These are the portions what we will see. So, the first one will be rectangle, this part, this entire part we will see it here like a trapezium. If we are aligning these entire views, perhaps front view, top view at bottom, from left direction we are seeing towards right direction. So, left side view. If we are getting that, we call first angle projection technique. So, this is the thing what we will get it. In the last class, I have asked you to construct this three-dimensional picture into projectional views. We have this kind of pin kind of structure. The answer for this pin kind of structure, the views what we are going to get. this entire portion turns out to be this one, and this entire triangular one we will see it in that way. There is a dashed line at that portion hidden from the back side. So, if we are looking from front view, this slot we will not be in a position to see that. That is the reason this is a dashed line. Similarly, if we are looking from top view, it is a first angle projection what we are trying to look at. So, this is front view, from top projected one, this is the top view. This entire rectangle we will see, this entire rectangle that comes out like that, and this entire inclined lines projected in such a way that we see a line, this entire thing, and this one we will see at middle. Again this part, the back side of that, this entire part we will see as one more line, that is this. This part we will see it like vertical. Similarly, on back side, whatever that vertical part, again this entire part we will see it like this one, and this one we will see it like that, and this part that we will see it in that way, and this entire line we will observe it in that way, and the back side parallel to that, perhaps if that is the line, again we will see it in that way. This is the way we look at these views and try to construct it. If it is something like from left direction, we would like to observe the right side onto vertical plane of right side, we have to project these points and so on. If we do that parallel to these lines, we are going to construct whatever this length we have, that length here, and there is a height, that height we are going to see here. So, this is the line, let us use other color. This part we will observe it in that way, and there will be a middle line. So, middle line from there, this entire inclined one projected onto vertical plane, which goes all the way up here. Similarly, this one all the way up here. This distance will be equal, like that we will get. Let us vertical line, and this one like a pin up to this level, because here we will be in a position to see this slot and so on. And if we are erasing this part, so let us re-show that. This is the view what we are supposed to get. Okay. Let us move on to next one. After working out that example, let us quickly look at difference between first and third angle projections for a typical automobile car. Let us consider there is an automobile car, that is this one, having some wheels, something like bonnet and boot space and so on, so stuff. This is the car what we would like to observe, having projections because projections are the ones which gives you true lengths in terms of how many millimeters, how many centimeters and so on, so things which we can't straight away get it from 3-dimensional because they will be a bit obscure. So, from projections, first of all we have to recognize which one is first angle projection, which one is third angle projection. For that example, we are picking this automobile car. On the front view, we would like to observe it in this direction. Perhaps side view will be that and top view will be that. And from bottom, if we are looking, what is that bottom view? These are the views what we are going to construct it now. So, let us first of all look at top view of a car. From this direction, we have to observe the top view of the car. That means, we can't straight away see any wheels, we can't straight away see anything like these inside of that parts. What we will see is the top portion of the car of that shape we supposed to see. So, let us observe those portions. So, the top portion, if we are trying to look at, there are lights here, something like this. This entire curved kind of portion, we will see that bonnet, and this top portion is this top portion of the car. The windshield, whatever we are observing from top side, that windshield we are going to see it here. The back side wiper and other things, that portion we will see it here. Similarly, the bumper portion and other stuff here we will see from the top view. Because this is first angle projection, when you are looking from top, the projection comes at the bottom level. So, if I am making this one as the front view, this one will be the top view. Let us observe one of the side view. If we are looking from left direction towards right direction, having a plane, whatever the projections we are going to get onto that plane, if I flip that plane, the way how it looks like is this. So, we will be in a position to see these lights, perhaps the seat arrangement, steering and other things, and some part of these tires also will be visible. So, that part of the tires, the name plate and so on, so on. Because this first angle projection, as usual, left side if you are looking, it comes onto the right side. So, the essential parts are the projections. The first thing what you have to observe, front view, top view and left side view, they make 90 degrees thing. The other thing, if we are joining these lines, they will supposed to get coincided, is projection. So, each point has to be projected onto that. Similarly, the extreme tangent, if we are going to draw, is supposed to match with this line. Similarly, this extreme tangent is supposed to go at that level. So, your entire view supposed to be bounded in between these lines. If we are looking from right side towards left side, that view what we call right side view. The right side view from this direction onto a plane we have to get. So, whatever the things, if we are going to project this entire thing, because this part will be visible, this part is non-visible. Let me tell you once again, onto this plane when we are projecting, what we will see is this mirror, perhaps if it is transparent, the steering, that also will be visible. Basically this bumper, these tires, this windshield and other things, we will see if we are looking from right side towards the left direction. So, this is back side portion, the back side seats and other things, the indicator lights and other stuff. Let us look at the bottom view. For a car, if we are looking from bottom side, the view whatever comes onto the top, that is what we call bottom side view underneath the car, which comes on top side of this front view. So, if you are looking from bottom side, the wheels, the shaft, differential and many other things, we will see that, the Ackermann mechanism and other things. Let us look at how third angle projection is different from first angle projection. In third angle projection, the object supposed to be in the third quadrant, and the third quadrant bounded by transparent walls, we have to project this entire object onto those walls, opaque and transparent walls, flip that, rotate these things at suitable locations, fold, unfolding kind of thing, then we will have this complete picture on third angle projection. Let us carefully look at it. The front view is not changing. In first angle projection, let us use two colors so that it will be clear for us. For first angle projection, the view, let us show it by red color. For third angle projection, let us show it by black color. There is no difference between first angle projection and third angle projection as long as front view is concerned. Top view, we look from top, construct the bottom one at bottom location, say that one as top view for the first angle projection. In case of third angle projection, when you are looking from top, it will be projected onto that top plane in the third quadrant, it comes at top level. So, it is more like a mirror, you have it on top side of the car in third quadrant, and whatever the projection you have it on that mirror, that if we are looking at it, we will get that third angle projection. So, your walls are mirror kind of objects, opaque from your side, but internally if you are looking that projection whatever we are getting on that third quadrant, that mirror if we flip it, see that we will get that projection. So, it is more like, let us consider this is the third quadrant, that means we have this wall goes all the way and goes, your first quadrant is here, your third quadrant is here, perhaps your car is located somewhere there, let us call this is a mirror, from top you can't see it, but because it is a mirror, whatever this object projected mirror, that object whatever we are going to see, that we are straight away getting by flipping this entire third one, open the third one, keep it there. So, it acts like a mirror. So, your top view straight away comes at top side, which is same as your top view in the first quadrant projection. So, in first angle projection the top view comes at bottom, in third angle projection your top view goes at top level. Now, let us look at side view. If we observe it from left side, the view will be projected on right side and we open that opaque plate, which will be same as left side mirror, because this is the mirror if we are observing it. if we are observing from this direction, this entire thing acts like mirror. So, whatever the projection from internally on that mirror happens, if I flip, whatever it comes, that we will call as the side view in third angle projection. So, let us use a black. So, your left side view comes on right side in first angle, in third angle it straight away comes on the left side. Similarly, the other views, first angle the bottom view goes at top, in third angle the bottom view comes at bottom. In first angle the right side view which comes on left side comes as right side for the third angle projection. So, the right ones will come on right side, the left one comes at left side, the top one comes at top side, the bottom one comes at bottom side. It's more like many mirrors are bounding that surface, and you open those mirrors, whatever those projections you already obtained, that is the way you get it. Let us guess few more projections. For example, we have this 3D kind of stand. Usually to suspend any shaft, for example, we would like to keep some shaft passing through that as a support or mast, something like a pole, we would like to hold it. Instead of just digging the hole, having this mechanical element which one can bolt it at this level. So, one can bolt it at this level, bolt it this level, having some kind of inclination, and one can really suspend a pole. For that purpose, we use this kind of object. If that is the case, can we draw these projections from this side? Because our terminology is wherever the arrow is there, that is the direction for the front view. This is the first thing. So, what are the things we will observe from front view? From top view and side view. Think about it. Okay, let us work it out. The front view. So, if we are observing in this direction, this part entirely will be visible. So, that part will be that. There is a circular hole which we can't see it. So, that is the reason here dashed lines which will be bounded by the diameter. So, those are the dashed lines. Mention it, it is a circle. So, we have an axis. So, that axis is dash dot line, and this is the baseline. Second, this part we will see, and further this inclined line goes all the way down. So, up to this part we have to see a line. So, up to that part we will see a line, and this part entirely goes all the way bottom, touch that. So, that entire part goes all the way touch there. Similarly, this part goes all the way there, then there is a horizontal line. This part goes all the way there and touch that. The exact dimensions based on the geometry we will construct it. Then we will be in a position to see that line, we will be in a position to see that line. This entire semicircle, that will be projected as one line on a plane. So, this entire part, this one, entirely we will see it like a straight line. So, that entire straight line is that. Similarly, at bottom the entire semicircle we will see it in that way. The edge, so it is more like such kind of object. So, this edge coincides with this edge, and there is a hole, circular hole. So, there will be minimum maximum kind of lines. So, dashed lines where this bolt extension we will see, and this is a circular hole. So, there is an axis line dash dot lines. This is the way front view looks like. Let us look at top view. Let us assume that is a first quadrant or first angle projection. In that, if we are looking from top, it goes to bottom side of this front view. So, this is the front view, bottom side we are supposed to draw this top view. For top view, what are the things we will see? There is a missing portion, this entirely filled by orange color. Let us consider this entirely filled by this orange one. Okay. From top view, we will see this line, we will see this line and this one. Similarly, it goes all the way there, it comes all the way there. So, that line, and there is a green patch. So, this line and this, it stops there because we start seeing this green portion from here to there. So, green portion from there to there, and again we will see this part, and this is the way we will see. And this entire part, projected version of this inclined one, we will see all the way there, and there is an extension outside of this. So, if we are drawing something like that is the line, this extension line we will see it here, and this semicircular portion we will naturally see, and this circle we will see it in that way, and these holes also we will see on that projection. So, holes with plus sign indicating that is the center, again holes, plus sign. This is the way we observe it, and if you are careful enough, here the center line and center line supposed to get matched, and these dashed lines, the whole thing, that and this whole position supposed to get matched, and here whatever this whole thing, they are also supposed to get matched, and this axis line supposed to match this. So, again this plus. This is the way the top view looks like. Our side view direction is this first quadrant first angle projection. So, it comes on the right side, that means it is supposed to come here. So, the lines you extend it is supposed to be in between these lines. So, if we are looking from this view, this entire rectangle, this banded line, and this one already projected, there is a circle. So, we will see in that way, and this entire circle line projected there. So, we will see it like a rectangle, and the remaining dash dot lines coincides with this circular positions. Something like that. This is the way we will see these things. Just be careful, whenever you are showing projections, you do not show these projections at random locations. You make 3 boxes. For example, first of all, one has to construct a front view. Below that, with certain gap, which we have seen, something like varying from 4 millimeters all the way to 25 millimeters kind of range, separated by top view, front view, and again there is a perpendicular box which comes on the other side for your side view, and these projection lines supposed to get matched. Similarly, these lines, such kind of things we are supposed to see. Like I said in the last class, when you are looking from top, these lines are hidden, material is not there. So, it is a good practice to show that on that plane. Thank you very much.